Hey guys, good evening everybody and welcome to the video. This video I'm gonna be demonstrating and showing you Kubernetes essentially auto scaling, basically horizontal auto scaling, which means as and when traffic increases, automatically it will create more and more pods. As traffic decreases, it will reduce the pod. So in my previous video, that is part number 5, if you haven't watched that part, I would recommend you to watch that. In that part, I essentially manually scaled up and scaled down. But in the night 2 o'clock, you don't want to go manually add more workers, reduce the worker. What I'm saying is in the day, you don't want to add workers, and in the night, since the traffic is down, you don't want to reduce it. You want to have it done essentially automatically, right? So let me show you a demo, right? So I have installed and configured something called Matrix Server, right? So you can come here. So you can say Matrix Server Kubernetes. So you can come here and essentially install on the. So if you come to the GitHub, they have the links to install that. I've already done that, right? So one quick note: when you do the Matrix server, there are a couple of files that were missing. So you have to make sure you add these lines, right? Commands. That's important because I literally spent 3 hours to figure it out, and then through a Stack Overflow, and I found it out. But yeah, add these 3 lines, and then essentially you can run your Matrix server by saying kubectl, kubectl. I'll say my kubectl apply -f. I'll say component.yaml. This should essentially, as you can see, configured, and here you should essentially see your Matrix server running, right? I already have done that, so I'm not gonna do it. So I'll show you that it is running. And by the way, all these snippets are there in the GitHub section, so kindly do not worry about the code snippets, right? So now let me show you. Let's make sure that the Matrix server is running. Usually it takes about 15 seconds to kick up. Yeah, it is running, as you can see, one-on-one, right? So that's running, that is great. Now I have a Flask application, right? Here is my deployment.yaml file, right? I'm adding one replicas here. The strategy I'm using is essentially rolling updates, right? What is interesting here is I am gonna run this. So here you can see I have a load balancer, right? So it's automatically gonna balance that. I want to have these pods created automatically, right? So first of all, I have this shell script that I'm gonna run that's gonna spin up my app, actually spin up the pod. So I'll say Python run shell.py. Okay. So after running this, it should essentially create the pods for me. So if you come here, let's wait at this point. And I'm actually going to show you because I'm going to increase the load using a Apache JMeter. I already have the test plan set up. Okay, so once the Docker image is built, I'll show you everything in action on it. It's fantastic, guys. So deploying. Remember, load balancing is the auto scaling is not done yet. So I've done that, and if I head over to my pod section. Here is my CPU and memory, but I should be able to filter out by. Here you go. So I have one instance, right? One running instance. Okay. If I come here, hopefully, hello from Python, right? Now let's roll the game, guys. Let's do an auto scaling, right? So because in the night you don't want to run. So in my previous video, that is part number 5. I ran these commands, right, to scale up and scale down. But I don't want to do that. I just want to have it done automatically. So here I'm saying kubectl deployment app deploy, that's the name, CPU percentile 20, minimum 1, maximum 10. So now it's gonna auto scale the load. So let's see the magic. Right, so the auto scaling already exists, right? So now what I'm gonna do is I'm gonna say kubectl get HPA. This should give me the CPU. Right now it is 1% app deploy, right? Literally nobody's using it, but now we are gonna heat this game up a little bit. So now here I have 300 requests which are being made in a matter of 1 second. These are making requests to the main domain, that is localhost, which is running on port 80. It should return new this, right? So as soon as I start this in an infinite loop, making a lot of requests, we should see the CPU spiking up, and we should see automatically more pods being added. Okay, so now my eyes are very closely I'm seeing here, right? But now let's take a look at the HPA. So we still have 2%, and remember it essentially updates after 15 seconds, so we're gonna wait. And as you can see, we are bombarding the web server with a lot of requests, right? So far it's doing good. I have about a little bit 20% of error rate. So now the pod should automatically scale up at this point. So let's wait. Let's see if we let's refresh this. In fact, so I should be seeing more pods that are being added. So if I click app and try to filter this, yeah, it's taking a while because now remember it's a little slow because I'm recording, and as you can see right now, auto scaling did kick up, and automatically we have four instances. Remember, the matrix server gathers the data after 15 seconds, right? So 985% because remember, I am continuously in every second I'm making 300 requests, right? So this is essentially gonna scale up, right? So if I go back to my pods essentially on a high level, and it's taking a while to load my dashboard too. It's a little slow. I understand that because I'm recording, my Docker is running, my Kubernetes is running, everything is being done on my local machine, right? So I understand it's a bit slow, but it's fantastic to watch. So as you can see, the CPU usage has been increased, right? And if you see, it's hard to, yeah. So if you see here, 1, 2, 3. So you added 3 instances. Now, if I try my best to again filter it out. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9 instances of your app, right? So if I now stop the load, right? So remember, I have stopped the load, right? I'm not making any more requests. Now automatically after 15 seconds, it should scale down, right? The load should scale down. And remember, my APIs, I can still access the API. It will do all that. See, it's always available, right? So Kubernetes is fantastic doing this job. So now coming back to my terminal and doing an HPA here, it's 686. So it's reducing now, right? Which means as the, and this one I can set it to anything that I want, right? A threshold, right? You could also do it on a memory, right? Based on memory, right? You could define that in the deployment.yaml file, right? As a resource, right? Minimum and maximum, right? But now, as you can see, after 15 seconds, this should start reducing. So now we are back to 2%, right? Over here. So what I want to show you now here is if I refresh my pods, if I try to cancel this, and then so this should come down after 15 seconds, right? Because it updates, the matrix server updates the data after every 15 seconds. We could configure that time easily, not a problem there. So let's wait. 1, 2, 3, 5, 6, 7. This should, so my pod should be reduced at this point. Let's search, try to filter with the app name here. So I still have 1, 2, 3, 4, 5, 6, 7, 8, 9 instances I have. So I'm gonna wait because I have just stopped my JMeter test. So kubectl, okay, now we are back at 2%, right? So this graph should come down, and then I should see, if I want to see overall here, I should be able to see the total number of pods, right? So right now there are 22 running there, and as you can see, right, after 15, it does update the chart, right? So now if I go to pods, they should update shortly. So as you can see here, right, there is a drop essentially in the CPU since I did stop the JMeter, right? So here also there is a drop. So here you can see there is a drop, right? So once it detects that, right, it should reduce my number of pods, right? So I'm gonna wait until that is reduced, and this graph should also update pretty soon. Okay, so we'll wait for a couple of more minutes. Okay, so that looks good. To app, it still needs to scale down, so I'm gonna wait and see if it does scale down, which it should in theory. right? I just need to wait for this matrix to come up. So the last one was that, there you go. There's a drop, you see. There is a delay, remember, because it updates after 15 seconds, right? So you have to wait for 15 seconds. Now, since I stopped, I saw a drop, and now my pod should automatically be deleted, okay? So I'm gonna wait, and I'm gonna show you that this actually works, right? So now let's go to work here. We still have 22 pods running, right? So let's see if this reduces or not, okay? Let's wait, okay? It's gonna do that, trust me. Oh yeah, it did already. So let me show you now. So I'll again filter this. Okay. Okay, I see. So if you observe it here, 7 minutes, 4 minutes. So let's wait. I'm gonna wait for 15 more seconds, okay? Because I know that it would remove these pods, right? So now, as you can see, right, this graph came down because of course I stopped. And remember, this interval is 15 seconds, okay? So you gotta be patient and then let Kubernetes do all the hard work for you, right? So meanwhile, that's happening. I wanna show you what my deployment.yaml. It's same from tutorial number 5. I have API version apps v1. We have a metadata here, kind as deployment. By default, I'm putting it one replica. Then here is where I define my specs. For example, the image name that I made, right? Then essentially I'm exposing the port, liveliness port. I have a health check, which does after every 2 seconds. I'm defining the resources as well, request CPU memory and the limit CPU memory. Then here I'm defining a service where it is type as load balancer. And then through kubectl command, I essentially put a auto scaling, right? I could have defined that in the YML file, which I'm gonna do in the next video, right? So now let me actually do get HPA. So yeah, it is under 2%. Yeah, so now it is pretty low. So I am expecting the pods to go down. Yeah, as you can see, guys, 14 pods, right? So now if you come here and if I show you, there you go, 2 pods automatically. I haven't done anything. Kubernetes automatically scaled up my pods as the request increases, and then scale down my pods. Absolutely fantastic, right? Absolutely fantastic. I was really impressed the way Kubernetes automatically did scale up my pods and scale down the pods based on the number of requests, right? A simple example I did using JMeter, and I saw a spike in CPU. Then I stopped it. Then automatically my pods were removed. Amazing, absolutely amazing. Thank you so much for watching. I'll leave the entire code in my GitHub section, which should be under lab number 5. I hope you have enjoyed watching such videos on Kubernetes. And if this excites you, you should also try to explore Kubernetes. It's so very fun, and there's a lot to learn in this. Okay. I have just touched the tip of the iceberg. I still have to explore Prometheus and Grafana, alerts, and there's just a lot more here. So we'll go with everything, right? And we have to ultimately go to the cloud as well, EKS and all of that. But all of that coming up in the upcoming videos, okay? So thank you so much for watching. I'll see you.